Yeah, good afternoon. So, in the last lecture, we have seen the theoretical part of the unit number 7, that is the roof truss. So, we have covered the basic components of the roof truss. Then we have seen the types of roof truss or types of trusses. Then also we have seen the various types of loads, and the loads are dead load, live load, and wind load that we are considering while designing the truss. Okay, so now we will see how to design the truss, and we will see the design procedure for the roof truss. So here, design of roof truss. Design of roof truss. So the procedure we will see. The procedure will be: step 1, step 1. Step 1 is from the span, comma, and roofing material, from the span, roofing material, decide decide the type of truss. So which type of truss we have to use, that type of truss we have to decide initially from the span of the your building. So this is step 1. Step 2, calculate spacing of truss. Calculate spacing of truss. And how to calculate spacing of truss? We have written the formula in the different terms used in the truss. The spacing of truss is what is how to calculate spacing of truss? We have seen 1/3 to 1/5 of span. 1/3 to 1/5 of span. By using this formula, we can calculate the spacing of truss. Then step 3. Calculate pitch or rise, pitch distance or rise. So pitch distance or rise is equal to, so how to calculate pitch distance or rise? We have written this in the different
1/3 to 1/4 of span.
1/3 to 1/4 of span. 1/3 to 1/4 of span, that is the pitch distance or rise. Then step 4, we have to calculate, that is calculate pitch angle. Or slope. So pitch angle or slope, that is theta, is equal to what is formula? Tan inverse of rise divided by span by 2, correct?
Yes, sir.
This formula also we have seen. Okay, so this is the step number 4. Okay, shall I go next? Please.
Yes, sir.
So step 5. Step 5 is calculate inclined length of principal rafter. Calculate inclined length of principal rafter. It means what? So this is the our, if this is the our truss. So what is the inclined length? So this is the principal rafter. So this is the inclined length. This is the inclined length of your PR, principal rafter. So how to calculate this inclined length? So this rise is known, this theta is known, this is span by 2. So how now span by 2 is known, rise is known. So how we can calculate?
Tan inverse.
Tan inverse of
Rise by span by 2.
this is a right angle. Inclined length is equal to this also right angle. So we can use rise square under root of rise square plus under root of plus span by 2 square.
Yes.
We can use that also. Span by 2 square plus rise square. So in this way also we can calculate. Or if with the theta, how we can calculate? By using theta.
Tan inverse of rise upon span by 2.
Tan inverse of rise upon span by 2. So tan inverse of rise upon span by 2 आपण theta calculate केला. Here tan inverse of rise upon span by 2. We have to calculate this inclined length. I think rise upon sin theta. Correct?
Yes, sir.
Or span by 2 upon cos theta.
Yes, sir.
So from many, by using this 1, 2, 3 formula we can use. Got it? Sorry for disturbance. Okay, so this is the step number 5. Then step number 6. So step number 6 is calculate inclined length of one panel. One panel, it means what? So if we use such truss, so here how many panels? 1, 2, and 3 panels are there. So total length is this. Total is the inclined length of principal rafter. Are you getting? Total length is a inclined length of principal rafter. Now this 1, 2, 3 I have written here. It means add the joint from this first joint to second joint. This is one panel. Second to third, second panel. Third to fourth joint, third panel. So again 3, 4, 5 panels will be there. So this one panel length we have to calculate. So for that we have to assume how many number of panels we have to provide there. So here how to calculate this inclined length of one panel? So inclined length of one panel is equal to inclined length of principal rafter, inclined length of principal rafter divided by number of panels. Number of panels. So here, so assume number of panels is equal to 4 to 6. So in this range, 4 to 6 range, we have to assume the number of panels. So are you getting how to calculate length of this one panel? So this is the length of one panel. So from first joint to second joint, how much length of panel is that? Is the length of one panel. And this length is, we can calculate total length divided by how many number of panel we have assumed. If we assume 4, if we assume 5, if we assume 6, then for this 4 to 6 we will get this length of this one panel. Are you getting?
Yes, sir.
टोटल लेंथला आपण अज्यूम केलेल्या नंबरने डिवाइड केलं तर आपल्याला तेवढे पॅनल्स या ठिकाणी असतील आणि एकाची लेंथ मिळेल. हे अज्यूम केलेले पॅनल टोटल इन्क्लाइंड लेंथ आणि त्याच्यावरून एका पॅनलची लेंथ मिळेल आपल्याला, कारण का आपल्याला एका पॅनलचा एरिया कॅल्क्युलेट करावा लागतो. कारण का एरिया कॅल्क्युलेट करावा लागतोय? दिस इज द पॅनल. कारण की ह्या पॅनल पॉइंट वरती किती लोड येतोय तो आपल्याला काढायचा. So for that we require these panel points. Okay. So in this way we can calculate the inclined length of one panel. Then step 7. Step 7. Calculate dead load. Calculate dead load, that is DL. So how to calculate dead load in Newton, that we will see here. So dead load we have seen in the last lecture, that is dead load in Newton per meter square. So that dead load we have to calculate. Okay. So number 1 here. Number 1 we have calculated weight of roof truss or weight of truss. So weight of truss we have calculated that weight of truss is equal to W is equal to span by 3 plus 5 into 10. Now this is in Newton per meter square. Now we have to calculate this load in Newton. this load in Newton. So for that we have to multiply by the plan area. So here multiply by, so weight of truss in Newton, here I am writing in Newton, weight of truss in Newton. So span by 3 plus 5 into 10 Newton per meter square into plan area of one panel. So plan area of one panel. So how to calculate plan area in one panel, that we will see. So plan area in one panel. So how to calculate plan area in one panel? See, this is the your inclined area of one panel. If 3 panels are there, so this is the your inclined area of one panel. This is the theta, and this is the your rise. Are you getting? So this is the inclined area of one panel. So plan area. So how we calculate this plan area? This is the inclined length. ह्या inclined length ला तुम्हाला काय करायचं आहे, प्लान लेंथ मध्ये कॅल्क्युलेट करायचं आहे. कसं करू शकणार? Okay, we will see at the time of solving example how to calculate plan area. Still, you can skip this, only write down this. Okay. Then second, weight of roof covering. Weight of roof covering. So or we so here I will, plan area is also simple. I will write down here. Weight. So how to calculate plan area? I will write here. Plan area of one panel is equal to span by 2, formula I am writing, span by 2 into spacing of truss. See, this is the inclined area. This is the inclined area. So now we have to convert into plan area. So span by 2. So this is the total span by 2, this distance. So wait, here we have to calculate for something went wrong. Wait. Wait, something went wrong. how we can calculate how we can calculate this length? This length we got total span by 2 length is known. Inclined length of one panel also we know. Then how we can calculate this horizontal length in plan? येते का लक्षात मी काय सांगतोय? So this is theta. This inclined length of one panel is known. So we have to calculate horizontal length. Who will tell me? हे span by 2. आपण एका पॅनलची काढतोय, लक्षात येते का? हे एवढे नंबर ऑफ पॅनल्स आहेत. 1, 2, 3 and 4. So this is the inclined length of one panel. Here I will indicate. This is the red indication is the inclined length of one panel. So we have to calculate horizontal length. This horizontal. Theta is known. Inclined length is known. In step number 6, inclined length of one panel calculated. So how we can calculate inclined horizontal length of one panel?
Inclined length into cos theta.
Inclined length into cos theta. Correct? Others, please. Inclined length into cos theta. Is this correct?
Yes, sir.
Inclined length of one panel, one panel into cos theta. काय मिळालं आपल्याला? प्लान एरिया मधली हॉरिझॉन्टल लेंथ मिळाली. येते का लक्षात? इनटू स्पेसिंग ऑफ ट्रस. Into spacing of truss. Where is spacing of truss? This is the spacing of truss. म्हणजे ही प्लान मधली लेंथ, हे बघा मी आता कॅल्क्युलेट दाखवलेलं जे लक्षात येते का तुमच्या? Whatever area I have shown by red color, are you getting this?
Yes, sir.
This area in plan and this whatever red indication, blue indicate area is in inclined. Blue area indicating inclined portion and red area I have shown that is in plan. So red area हा एका पॅनलचा प्लान मधला एरिया झाला. सो this length, this into this two length ह्या दोन बाजूचं मल्टिप्लिकेशन म्हणजेच प्लान एरिया आला ना?
Yes, sir.
हा, मग आता त्यातली एक ही बाजू, फर्स्ट क्वेश्चन मार्क, दिस इज फर्स्ट क्वेश्चन मार्क, दिस इज सेकंड क्वेश्चन मार्क. सो फर्स्ट क्वेश्चन मार्क इज अ inclined length of one panel into cos theta. ही मिळाली बाजू, बरोबर आहे का आपल्याला? And second number line is a spacing of truss. So this is the spacing of truss. Are you getting? आलं का लक्षात सर्वांच्या? हा फॉर्म्युला प्लान एरिया ऑफ वन पॅनल, एका पॅनलचा प्लान एरिया कसा कॅल्क्युलेट केला लक्षात आलं?
Yes, sir.
Okay. So now I will again this is the one panel. So this is the one plan area, sorry, inclined area. This is theta. Now this inclined area you have to convert into this plan area. So now this is spacing between truss, spacing of truss, and this is the inclined length of one panel into cos theta. So these two sides we have shown here in this particular plan. So I think now got it everyone this. Okay. Okay. Shall I go on the next page?
Yes, sir.
Okay. So number one, weight of roof truss is over. Now number two, weight of roof covering. Weight of roof covering. So weight of roof covering is equal to, again, weight of covering into, again, plan area. This is in again Newton. So plan area of one panel. So weight of covering for AC sheet, how much? For AC sheet 120 to 160, and for GI sheet 100 to 150.
150.
So this we have to put here. Weight of covering means इथे 120 ते 160 आणि 100 to 150 पुट करायचं आहे, आणि प्लान एरियाने परत मल्टिप्लाय करायचं. आता प्लान एरिया कसा कॅल्क्युलेट केला लास्ट स्टेप मध्ये कळालं. देन नेक्स्ट, वेट ऑफ पर्लिन in Newton. So again here, weight of purlin in Newton per meter square, हे पण Newton per meter square मध्ये आहे, into plan area of one panel. And number four, weight of bracing is equal to, in Newton, again weight of bracing in Newton per meter square into, again, plan area of one panel. So now total dead load is equal to 1 plus 2 plus 3 plus 4 in Newton. Got it? All the loads we have calculated now in Newton, because Newton per meter square area is there, so we have multiplied by panel area. So if we multiply by panel area, this meter square get cancelled, and we will get the load in meter. So we will get the load in Newton. Got it? So total dead load is equal to addition of this 4 in Newton. So the total load will be in the Newton. Okay. So now dead load on, this is the total dead load. So dead load on intermediate panel point. Dead load on intermediate panel point is equal to total dead load divided by number of panels. So we have assumed number of panels is in Newton, and dead load on, I will show this how this load will be transferred. Dead load on end panel point, dead load on end panel point is equal to dead load on intermediate panel point divided by 2 in Newton. So total dead load we have calculated. From this total dead load on intermediate panel point and dead load on end panel point means what? That way I will show you. So please write down first, and then I will draw the sketch and I will tell. Panel point. Okay. So that panel point, which are this intermediate panel point and which is the end panel point, that I will show. First write down this. कसा लोड डेड लोड ट्रान्सफर होतोय त्या पॉइंट वरती ते दाखवायचे तुम्हाला. ओके. Is this over?
Yes, sir.
Okay. So now this is the word truss. This is the word truss. If okay, so these are the your panel points. Are you getting? Okay. So this is 1, 2, and 3. If you assume four number of panel, then you will get this 3. So these are the intermediate panel points. These are the intermediate panel points. These all are the intermediate panel points. Are you getting? And now here two points are there. And this is the end panel point. This is the end panel point. म्हणजेच काय तर याच्या अर्धा एरिया या पॉइंट वर जातो, अर्धा एरिया इकडे येतो. याच्या अर्धा एरिया इकडे ह्या पॉइंट वर जातो, अर्धा इकडे येतो, अर्धा इकडे जातो. म्हणजे जे इंटरमिडिएट पॅनल पॉइंट आहेत त्याच्यावरती किती येतो? फुल येतोय की नाही बघा. इंटरमिडिएट पॅनल पॉइंट रेड कलरचे जे पॅनल पॉइंट आहेत, या पॅनल पॉइंट वरती इकडच्या अर्धा एरियाचा, इकडच्या अर्धा एरियाचा, याच्यावरती इथल्या पॅनल पॉइंट वरती इकडच्या अर्धा एरियाचा, इकडच्या अर्ध्या एरियाचा, आणि याच्यावरती पण इकडच्या अर्ध्या एरियाचा आणि इकडच्या अर्ध्या एरियाचा. म्हणजे इंटरमिडिएट पॅनल पॉइंट वरती जेवढे काय पॅनल आहेत त्या पॅनलचा एका पॅनलचा लोड हा या इंटरमिडिएट पॅनल वरती येतोय. म्हणजे अर्धा इकडचा प्लस अर्धा इकडचा, म्हणजे टोटल एक असा लोड या इंटरमिडिएट वरती येतो. म्हणजेच आपण इफ यू सी दिस फॉर्म्युला, डेड लोड ऑन इंटरमिडिएट पॅनल पॉइंट, डेड लोड ऑन इंटरमिडिएट पॅनल पॉइंट is equal to total dead load divided by number of panels. So total dead load जो काय आपण कॅल्क्युलेट केला 1 + 2 + 3 + 4. So this total dead load divided by number of panels. So the number of panels are 1, 2, 3, 4. So total dead load ला 1 plus 2 plus 3 plus 4 divided by 4 केलं, whatever load will become, this load will be on this end panel. मग मधले जे आहेत त्याला आपण इंटरमिडिएट पॅनल. सो जे मधले पॅनल्स आहेत सगळे पॅनल पॉइंट्स, सो दीज रेड इंडिकेटेड पॉइंट्स आर दी intermediate panel points and these indicated points are the end panel points. मग एंड पॅनल पॉइंट्स वरती अर्ध्याचा लोड जातोय की नाही हो, अर्ध्या पॅनलचा. बघा स्केच मध्ये बघू शकता. If you see here, see this is pan point, this is point, this. So if these 4 points are there, मग हा होल पॅनल आहे, ह्याच्या अर्धा म्हणजे अर्धा लोड इकडे जाणार आहे. म्हणजे इकडचा अर्धा प्लस इकडचा अर्धा हा एक पॉइंट होतोय की नाही, इकडचा अर्धा प्लस इकडचा अर्धा हा एक पॉइंट, म्हणजे हा लोड आणि हा लोड. म्हणजे इंटरमिडिएट पॅनल पॉइंट वरती जेवढे नंबर ऑफ पॅनल्स आहेत डिवाइडेड बाय तेवढे पॅनल्स केले की तुम्हाला या पॉइंट वरचा टोटल लोड मिळतोय. आणि एंड पॅनल वरती कुठला जातोय हो, एंड पॅनल वरती फक्त ह्या अर्ध्याच एरियाचा जातोय की नाही, इकडच्या एंड पॅनल वरती ह्या अर्ध्याच एरियाचा जातोय की नाही. म्हणजे एंड इंटरमिडिएट वर जेवढा येतोय त्याच्या अर्धा एंड वरती जातोय. सो whatever formula here we have written, dead load on intermediate panel point is equal to total dead load divided by number of panels, and dead load on end panel point is equal to dead load on intermediate panel point divided by 2. Are you getting this?
Yes, sir.
हे लक्षात आलं का? ते खूप इम्पॉर्टंट आहे. लोड कोणत्या पॉइंट वरती कसा, आणि which is the intermediate panel point and which is the end panel point, that is the very important. Okay, so in this way we can calculate the dead load. Now next step, step number
8.
Step number 8. So step number 8 is a calculate live load, LL. So live load is equal to, we know the formula, live load is equal to W is equal to 750 minus theta minus 10 degree into 20. This is in Newton per meter square. So if we multiply again plan area of one panel, if we multiply plan area of one panel is equal to, we will get this W is in Newton. Got it? This W is in Newton. So again same, and this is the actually total live load. Total live load is equal to this. So now live load on intermediate panel point. Live load on intermediate panel point is equal to total live load divided by number of panels. And live load on end panel point is equal to total live load on intermediate panel point intermediate panel point divided by 2 divided by 2. So in this way, we can calculate the live load also. So dead load and live load on the each panel point we have calculated here. So same, so similar to dead load, same load will be transferred on the. So actually this is the your panel. This is your panel. So these are the points are there, panel points. So the load acting like this. So load acting like this. Are you getting? So in this way, the load will act and that load will be transferred half on this point, half on this point. Half this area, half this area. So similar, this will be the sketch for the live load also. That sketch we will draw in detail in while solving the example. Okay. So now most important and critical load is the live wind load. So for the wind load calculation, there will be a much time will be required. So we will see the wind load calculation in next lecture. So we will stop here for today and we will calculate the wind load in the next lecture, because for wind load calculation we require 1.5 hours or at least 1 hour is required to calculate the wind load or do the calculations of wind load. Okay, so we will see the how to calculate wind load in the next lecture. So we will stop here today and wait, I will take attendance and we will close. You can join next lecture. So wait.